Fourth unit in digital image processing technique is image restoration and segmentation. Image restoration. It deals with improving the appearance of an image. So, restoration is the process that reconstruct or recover an image that has been degraded by using a clear knowledge of the degradation phenomenon. It is based on mathematical tools of image degradation. So, actually, the image degraded by sensor noise, blur due to camera focus, otherwise relative object camera motion, and random atmospheric turbulence. So this is the basic block diagram of image degradation and restoration model. So f of x comma y, degradation function in terms of h. So after degraded, the image is added with noise. So g of x comma y is equal to function of degradation with additional noise, e of x comma y. So the degraded image is given to the restoration filter. So we are applying different restoration techniques which is used to restore the original image. So here f of x comma y is the restored image and f of x comma y is the original image. So here f of x comma y is the input image or original image and e of x comma y is the noise and h is the degradation function. So here g of x comma y is represents a degraded image and f cap of x comma y is the restored output image. If f cap of x comma y is equal to f of x comma y means no error. So here e of x comma y equal to 0. So the degraded image is represented in the spatial domain as h, degradation function h of x comma y is multiplied by f of x comma y, original image, plus e of x comma y, external noise. So this is the spatial representation of degradation function. So degraded image is represented in terms of frequency domain. We are applying transform. Then after that, the x and y coordinates are converted into u comma b and each letters are represented in terms of capital. So g of u comma b is equal to h of u comma b into f of u comma b plus eta becomes noise n of u comma b. Here h of u comma b is the Fourier transform of h of x comma y and f of u comma b is the Fourier transform of f of x comma y and n of u comma b is the Fourier transform of eta of x comma y. Then another topic is noise model. Here the source of noise in digital images are arising during image acquisition and transmission time. Image sensors can be affected by environmental conditions and interference can be added to an image during transmission. Hence, noise cannot be predicted, but it can be approximately described in statistical way by using the probability density function. So, some noise probability density functions are Gaussian noise, Rayleigh noise, Erlang or gamma noise, and exponential noise, uniform noise, and impulse noise. So, it is salt and pepper noise. Then, so we are using restoration techniques. We can able to perform the original image from the degraded image. Okay, this is one. Then segmentation. Here segmentation is the process of partitioning or dividing an image into its constituent parts or objects. Here computer tries to separate objects from the image background. Example, segmentation of tumor part in MRI brain image. In general, autonomous segmentation is one of the most difficult tasks in digital image processing. Segmentation algorithms are based on two basic properties, namely discontinuity and similarity. So how to detect discontinuities? So detection of discontinuities are three types. One is points, lines and edges. Then to identify these discontinuities, mask processing is performed. The response R of the mask is identified with respect to its center location. So here mask patterns coefficients are represented in terms of W and the original image is F. So we are applying the mask pattern to this original image in terms of Z. So R is equal to W1 Z1 plus W2 Z2 up to W9 Z9. So which is mathematically represented in terms of summation of I is equal to 1 to 9 Wi and Zi. Then point detection. So this is the mask coefficients of point detection minus 1 minus 1 minus 1 minus 1 8 minus 1 minus 1 minus 1 minus 1. So this is the coefficients for detecting point. So here the response of mask at any point in the image is defined by uh, in general, W1 is at 1 plus W2 is at 2, etc. W9 is at 9. So here Wi represents the mass coefficients and Zi represents the gray level of the pixels. Okay. Then line detection. See, actually detection of lines are represented in terms of horizontally, vertically and plus 45-degree angle and minus 45-degree angle. Four types of marks are used to get the response for the directions. So the directions are horizontal, vertical, plus 45 degree and minus 45 degree. So the mask for detecting horizontal line is minus 1, minus 1, minus 1, 2, 2, 2, minus 1, minus 1, minus 1. And mask for detecting vertical lines are minus 1, 2, minus 1, minus 1, 2, minus 1, minus 1, 2, minus 1. And mask for detecting 45 degree plus 45 degree line. So 2 minus 1 minus 1 minus 1 2 minus 1 minus 1 minus 1 plus 2. And for detecting minus 45 degree line, so the mass coefficients are minus 1 minus 1 2 and minus 1 2 minus 1 2 minus 1 minus 1. Then edge detection. An edge is a set of connected pixels that lie on the boundary between two regions. It provides an outline or boundary of the object. Actually, edge detection is an image processing technique for finding the boundary of objects within the image. It works by detecting discontinuities in gray level or intensity.